Hi, my name is Charles Kaplan. I'm a professor at the State University of New York at Old Westbury. This video works out a normal distribution problem, type problem that you'd receive in a basic probability and statistics class, or even in a little bit more advanced mathematical statistics class. So let's take a look at the problem. The mean hourly cost to operate a mid-size aircraft is $2,100. Actually, right, per hour. The standard deviation is $250. The costs are normally distributed. What is the operating cost for the lowest 3% of the airplanes? Okay, so let's start off by writing down the information that we know. We know that the mean is 2100, and we know that the standard deviation is 250. And the problem wants to find out, the problem asks us about the lowest 3%. So let's put a normal curve up here, the best that I can with my limited drawing skills. And we're interested in this portion down here, the lowest 3%. Well, now let's see, we've got to convert this to some z values. Okay, so what we're going to do here, we know how much area is in the tail in the bottom half of this problem. All right, we know that there's 3% in there. What we don't know is what the x value is over here. We don't know what the costs are, but we know that 3% of all the observations are going to be in this tail. So we have a z transformation formula, z equals x minus mu over sigma. Now, ordinarily, when we use this problem, we know what x is, we know what mu is, and we know what sigma is. And we use those to calculate z. In this case, we're going to find out what z is very quickly. And we know that, well, if we have 0.03 here in the tail, we have 0.47 in this region. And of course we have 0.5 in this region. So we need to find in our table, in our z table in the back of the book, an area associated with 0.03. Well, we see that this book is giving us the area associated with the central location. That, if you look in here, is 0.47. So what we're going to do is we're going to look up 0.47 as an area in the table here. And if we go over here, we see that, well, we don't have 0.47 exactly, but we do have something pretty close, 0.4699. And that's associated with a z value of 1.8. And we go over here to the 0.08 column. So it's associated with a z value of 1.88. And because it's on this side of the mean, it's negative 1.88. So what we're going to do is we're going to use negative 1.88 as our z value. We don't know what x is, that value here. We don't know what that's associated with yet. We know that the mean is 2100, and we know that sigma is 250. So let's multiply both sides of this equation by 250. Negative 1.88 times 250 is negative 470. That's equal to x minus 2100. And we're going to add 2100 to each side. So this is 1630 equal to x. So now we know that this x value is 1630. And in this case, it's dollars. So it's the operating cost. So we know now that the least or the lowest the planes, the 3% of the planes with the lowest operating costs, those costs are $1,630 per hour or less. So the mean is 2,100, but these planes, I guess, are relatively easy to service, and that 3% is going to be 1,630 or less. So let's go back through and see how we solve this problem again. We were given a mean of 2,100 and a standard deviation of 250. That mean 2,100 is here. We were asked about the lowest 3%. We didn't know when we started what that x value was, but we looked up in our z-value table and we found that, well, associated with 0.47 here was a z-value of negative 1.88. We then used our z transformation formula, plugged negative 1.88 in for z. We still don't know what x is. That's what we're trying to solve for. And then we substituted 2,100 for the mean, 250 for the standard deviation, and we went ahead, it's just algebra, and we solved for x, which turned out to be 1,630. Now, I just want to remind you of one important thing here before I finish, and that's these x values, 2,100 and 1,630, those are dollar amounts, right? Operating costs per hour. The z values, 0, remember the standard normal distribution has a mean of 0 and a standard deviation of 1. The z values are units of standard deviation. So in this particular problem, the x values are units of dollars, but as always, the z values are units of standard deviation. So this $1,630, this is 1.88 standard deviations from the mean. That's what this 1.88 represents. It's units of standard deviation. And that's what we get when we transform x minus mu divided by sigma. So I hope you found this video helpful. If you did, I'd appreciate if you leave a positive comment. Again, my name is Charles Kaplan, and I wish you all good health, good happiness, and the best of luck. Bye-bye.